Hello statistics student, this video is for chapter 12.5 prediction. In the last video, we used statistics to calculate a linear regression equation if the matched pair data is linear related. And this is the equation is called line of best fit because it's like right in the middle of all the points where the sum of the differences for the prediction and the observation is the minimum. Okay, so oh, there's typo here. So we are going to use that for predictions only if we satisfy this criteria. So we can use so don't just use it whenever you can if you find the equation, because even if the x and y are not linear related, you can always find a the linear regression line. So look at here. If I have a go to stat this, and I just write something that is not linear related, like what earlier height and shoe size are not, right? So let's say 4, 5, 6, 2, 4. And then I'll just do add a number, add a new column, add one column, go. Let's say 19, 18, 25, 4, 8, they're just really random. And then we can graph it. Okay. We can do the regression analysis for 5 and 6, right? 5 and 6. This is randomly driven things. So you can see that, oh, actually the p-value is quite good. The p-value is 0.07. It should be greater than 0.05. So there's no linear correlation, right? Do you agree? Oh, actually, it's actually quite good. But because the results show there is no linear correlation, but they always give you a line, right? So even if you have something that is not related, they don't stop you. They always will give you this regression line. So don't look at the scatter plot and say that, or don't look at this match pair data and then calculate the regression results and use it for prediction. You only use it for prediction if the correlation coefficient or p-value shows that there is linear correlation. So this is the most important thing for prediction. Okay. Okay, so we'll go back to the notes. So first is, so what is the criteria is you always look at the scatter plot first to see that it's only a up or down pattern, but no other one. You also watch out for outliers. The second most important thing is to check that the match pairs are linear correlated. Because instead this correlation and regression are all done in one set of function program, so you can get the p-value to check it. And number 3 is when you do prediction, don't plug in anything that you want x to be. The range of x, it has to be within the prediction domain. So what is the prediction domain? That is the x value that you have in your data. Like if this is x, so you remember I graphed the number, I labeled them. So I know where it starts and where it stops. Okay. So if the number is from 10 to 20, you only predict for x between 10 to 20 for prediction. You should not plug in x equal to 30 for prediction. Okay, so this domain is the prediction domain that you can use the line for, but not outside. The other requirement is when x distribute around this line, or for a certain x, sometimes you have multiple y, right? So the same x, you have multiple y. So the distribution is normally distributed. So, but this is a loose requirement. It doesn't have to be very good, but it rules out the fact that if you have a lines that is, if you have points go like this, it's spread out really, far away here, but at the end, it's really close. Then it doesn't seem like they're normally distributed. Okay, so be aware of those requirements. So how do you find the best prediction for y? First of all, always verify the linear regression, find the p-value and the scatter plot. So the first things you do is find out three things: the equation, p-value, and scatter plot. All of these can be found under correlation and regression. So under correlation and regression, enter your significance, enter the data column, and then you would have to critical R, p-value, B0, B1, R square, and the scatter plot. So these are all the ingredients that you use. So I can show this to you. So if I want to do a child's shoe size and also math score, I want to do it again. So the things that I will write down is R, critical R, p-value, so that I can use it to verify. I write down the equation B0, B1 for prediction, and I would also take a look at the scatter plots to see if there's any unusual pattern. Okay, so that's the first things you do. And then step 2 is check the scatter plot for linear pattern and inspect if there's any non-linear pattern or outliers. Step 3 is look at the p-values. If p-value is less than alpha, then conclude they are linear related. If p-value is greater than alpha, then there's no linear correlations. We talked about those before. And then if R is outside, or you can use critical R and R if you want to. If R is outside of the critical range, critical value range, then they are linear related. Now, if they pass all these, that means scatter plot looks good, the p-value looks good, then you can use it for prediction. You should also check X, right? Is X in the predicted range? I didn't write this down. So make sure that X is in the check that X is in the prediction range. The prediction range are the data that the X values of the match pair data. If it's outside, you do not use it. So you plug in your X here and you calculate that is Y hat is the predicted Y. Now, in case your p-value is greater than alpha, that means there's no linear correlation. So if X, Y are not linear related, then what do I use to predict? Do not use it. Use Y bar, the mean of Y as the predicted value of Y. If you do not have Y bar, you can use Statistics Explore data to find the mean of Y. So how good is a prediction? So earlier we also asked you to copy down R squared, right? The coefficient determination R squared will describe how good the linear regression is in predicting the variation of Y. So when Y change, it can be predicted by the line. Okay. So example 1, I have we want to look at if screen time is related to your sleep time. So here, this is another study, 5 data. I don't need I only need the number. Okay, copy it. And we want to do it relation, and also we want to use it to predict. I think we want to do some prediction also. Okay, so let's go to Statistics. Erase this and also clear all. Okay, copy the screen time and sleep time. You can edit the column. So this is screen time. So how many time you spend, and this is sleep time. Of course, if you do too much screen time, your sleep time will suffer, right? So now we want to see if there is linear correlation. So the only thing you do is correlation, regression, screen time, sleep time, evaluate. So write down what do we need to write down? We need to write down coefficient R, negative 0.579. P-value, 0.306. The number, in the equation, B0 is 9.774. Slope B1 is negative 1.099. 3 decimal places. And also R square is 0.3356. And you should also look at the scatter plot. So ignore the lines, just look at the points. Do you see any unusual pattern? Well, we only have 5 data, so it's hard to see if there's unusual pattern. But anyway, you copy this down. You copy to make sure that the x-axis is from 1.5 to 3.5. The y-axis is from 6 to around 10. Okay, 6 to 10, and you know the location of the points, rough location of the point like that. So this seems to be an outlier though, right? And now let's go back to the worksheet. Let's go back to the worksheet. So here I have all the data here. R is negative 0.579. I've written it down. B0, B1. I didn't copy down R square, so I should say R square is 0.3356. So once you have those, R squared equal to 0.3356. So check the scatter plot. So there's no systematic nonlinear pattern, right? So like what I have promised, we should write down this 1.5 to 3.5. So 2.5, right? And then here we will say 6 to 10. 8 is here, right? Yeah, 7, 9. So you label them, and then what is this? This is the screen time, right? So when you do your class worksheet, please write them down. And this is sleep time. No systematic nonlinear pattern. It seems to be a weak negative correlation. But is there correlation? Let's look at p-value. P-value is 0.306, right? It's greater than 0.05, so no linear correlation. Can I use it for? And you can also check that your R equal to 0.579 cannot pass through the threshold, right? The threshold is 0.878 and negative 878 and positive 878 is trapped in 0, so there's no correlation. So if they're not correlated, the best predicted value is the mean of Y. So calculate the mean of Y. Go back to data, explore data. And we just want to know sleep time because we want to predict sleep time. So just do Y sleep time. The mean is 7.4, right? So you will say, well, the best prediction is 7.4. We don't use this linear equation. Although we write it down, we don't. Okay. So then we have another example, which is study hours and final score. So we will do it in the next video.